Bridges Project by William Meyer, aka Bob the Builder. Yay! Beam bridge mechanics. At first, a horizontal beam carries vertical load by bending. As the beam bridge bends, it undergoes horizontal compression on the top. At the same time, the bottom of the beam is subjected to horizontal tension. The supports carry the loads from the beam by compression vertically to the foundations. Prestressed concrete is a particularly effective material for beam bridges because the concrete can resist the forces of compression, while the embedded steel withstands the forces of tension. Concrete is also the most cost-effective material, given the bending inherent in beam bridges. Both simply supported and continuous beam bridges are limited to relatively short spans between supports. In general, the distance between supports is not more than 250 feet, or the bridge stability is compromised. Maybe give yourself a minute to think about that. Beam bridge construction. In the case of a typical overpass beam bridge with one support in the middle, the construction begins with the casting of concrete footings for the pier and abutments. Where the soil is especially weak, wooden or steel piles are driven to support the footings. After the concrete piers and abutments have hardened sufficiently, the erection of a concrete or steel superstructure begins. Steel beams are generally made in a factory, shipped to the site, and set up in place by cranes. For short spans, steel beams are usually formed as a single unit. At the site, they are placed parallel to each other with temporary forms between them so that a concrete deck can cast on top. The beams usually have metal pieces welded on their top flanges around which the concrete is poured. These pieces provide connection between beam and slab, thus producing a composite structural form. Tension and compression. Tension forces pull and stretch material in opposite directions, allowing the rope bridge or any bridge to support itself and the load it carries. Compression forces squeeze and push material inward, causing the material of a bridge to press against each other to carry the load. Pictures of construction. The first one, all of them. Just what I'm doing. This is how I made road panels, kind of a tile-y thing. And here are the piers. Kind of go inward for a smooth transition. Then this is some of my failed parts of the bridge. Piers. And here's the bridge. You can't really see it. Here is me testing compression, but the weight is below. Okay, this is long. And with the weight above. In the first picture, my sister is holding 41.2. The bridge is holding 41.2 pounds. In the second picture, 65.7 pounds. Then in the last, my dad is 217.6 pounds. Still held. Wow. Also, this thing holds more than 250 pounds.